I'm Yuko Tousen from the National Institute of Health and Nutrition in Japan. It's a great honor to have this opportunity to present at today's symposium. Thank you very much for having me. Today, I will present our recent work on the development of a nutrient profiling model for dishes in Japan and its applicability across Asia. Here is an outline of what I will talk about today. This slide shows typical example of Japanese meals and dishes. On the left, you see a traditional meal consists of rice, miso soup, grilled fish, smeared vegetable, natto, boiled greens, and pickles. On the right are other popular dishes such as sushi, deep fried items, hamburger steak, udon, katsudon, curry rice, omurice, and ramen. Japanese meal consists of dishes that combine multiple foods flavored using the traditional seasoning such as soy sauce and miso. Compared to Western meal, Japanese meals tended to be lower in fat, animal protein, and sugar, but higher in sodium. In our research team, we first focused on Japanese major nutritional challenges to consider what kind of nutrient profiling model is needed. Excess sodium intake is the most critical issue in Japan. On average, Japanese men consume 10.9 grams and women 9.3 grams of salt per day, nearly double the WHO recommendation of 5 grams. About 70% of dietary salt intake comes from seasoning, such as miso and soy sauce and salt. At the same time, these seasonings are essential to Japanese meal and are deeply rooted in our food culture. Various nutrition profiling models are already used globally. However, most of them were developed for Western processed foods. Existing NP models are not suitable for evaluating Japanese food and dishes. How should seasoning and cooking oil in dishes are assessed? Therefore, we developed a nutrient profiling model for dishes in Japan, NPM-DJ. This model aims to encourage food business operators to develop and reformulate healthier dishes. Finally, it is intended to support the consumer in choosing healthier dishes. This model is a public and neutral tool to support the development of healthy food environment. From here, I will explain the concept and design of NPM-DJ. Let me briefly explain the outline of the evaluation process for NPM-DJ. The basic scoring algorithm is the same as used in existing NP model for processed food in Japan, Dr. Takebayashi introduced. However, a processed food model evaluated by 100 grams or 100 milliliters, while NPM-DJ evaluates dishes per serving. The target population is adult and age aged 17 years and over. The evaluation consists of 5 steps here. Step 1, dish categorization. This is explained later. Step 2, calculation of baseline point. In this step, the focus is on negative nutrients such as energy, saturated fat, sugar, and sodium. Step 3, calculation of modification points. In this step, the focus is on positive nutrients, including protein, dietary fiber, and components of such as vegetables. Step 4, calculation of the final score. In this step, the final score is calculated as baseline point minus modification point. Final step. Dish rating determined by score-based ranking. In this step, dishes are evaluated within their classification category and ranked on the relative scale. First, I will explain the dish classification in NPM-DJ. The model classifies dishes into 5 categories. Here, staple dish, side dish, main dish, mixed dish, and mixed dish with staple. Detail of each category will be introduced later. This dish classification was developed based on framework of Japanese food guide Spinning Top and by utilizing data from National Health and Nutrition Survey in Japan. After analyzing several classification patterns, we decided on these 5 categories. By incorporating mixed dish and mixed with dish staple, the model can accommodate a wide range of dishes consumed in Japan. Next, I will briefly introduce the Japanese food guide Spinning Top. This guide promotes balanced meals with staple dish, a main dish, and side dish. It serves as the basis for dish classification in NPM-DJ model. Following this guide has also been linked with the better healthy outcomes, including lower risk of cardiovascular diseases. For this model development, we use 105 dishes listed in the food guide serving quick reference table. We considered these representative or basic dishes commonly consumed by Japanese people. Even for the same type of dish, ingredients or portion size can vary. In this study, registered dietitians create standardized recipe based on the listed ingredient and their amount. We then calculate the nutrient value for each dish using these standardized recipe. This slide shows a flow chart illustrating the classification process for each dish. First, we ask, does the total weight of the ingredient on the right side exceed 2/3 of the total weight of the dish? If yes, the dish is classified as a staple, side, or main dish, depending on food group of the main ingredient. If no, we check whether staple component is less than 0.5 SV. Based on this is classified into mixed dish or mixed dish with staple. Mixed dish are meals with a combination of various ingredients, for example, sweet and sour pork. Mixed dish with staple includes such combination with a staple food, such as curry rice. Step 2 to 4 I will explain how the final score is calculated. To illustrate the process, I will use smeared Hijiki sweet as an example. In step 2, we calculate the baseline point based on negative nutrients, energy, saturated fat, sugar, and sodium. Nutrient values are calculated by serving, and scores are assigned using predefined scoring table. In step 3, we calculate modification point for positive nutrients, including protein, dietary fiber, vegetables. Contents. In step 4, the final score is obtained by subtracting the modification point from the baseline point. In final step, these dishes are ranked based on the final score within each dish category. Ranking is determined using 10% interval for each category. For example, in side dish category, a dish with final score of -6 falls into rank 4.5. Let me explain some important notes shown here. A ranking may vary depending on the number of dishes included and the distribution of points. The model was evaluated using 105 standard dishes in the study. Not all dishes commonly consumed in daily foods are reflected in the evaluation. Next, I will explain the nutrition characteristic by dish category in the baseline points. We show the baseline points which are based on nutrients we want to limit, such as energy, saturated fat, sugar, and sodium. For example, a mixed dish with staple had a higher value of energy, saturated fat, so a baseline point is higher. In contrast, a side dish had lower energy and lower baseline points. We calculated modification points based on positive nutrients such as protein, dietary fiber, vegetable contents. Here, main dish often scored higher for protein, while side dish has vegetable points. In final score, the side dish shows lower value, while mixed dish with staple showed higher value. This model can also reflect how these dishes are eaten. For example, in noodle dish udon, the final score changes depending on whether the broth is fully consumed. If the broth is not consumed, sodium intake is reduced and the score improves. In this case, the star rating goes up by 1 level. This feature may help promote healthier eating behaviors such as leaving the broth. This slide shows 4 key highlights of Japanese NPM-DJ. First, a model designed to address Japanese nutrition issues. This means the model was created to respond to Japanese specific dietary challenges. Second, utilized data from the Japanese Food Guide Spinning Top and National Health and Nutrition Survey. These national data set form foundation of the model. Third, dish-based evaluation allows for realistic assessment of seasoning and oil used in cooking. By evaluating dishes, the model reflects actual cooking practice. Four, the first dish-based nutrition profiling model developed by a government affiliated institute in the world. This is one of the important strengths of the Japanese NPM-DJ. From here, I will introduce the applicability of the NPM-DJ concept across Asia. This slide showed example of meals from several Asian countries. As shown here, meals in many Asian countries consist of multiple dishes, and this meal structure is similar to Japanese meal pattern. Because of this similarity, the dish-based NPM-DJ fits Asian food culture very well. So we believed that the concept of NPM-DJ can be naturally applied to many Asian countries. This slide shows the food-based dietary guidelines from several Asian countries. Many Asian countries have food-based dietary guidelines. These guidelines are based on local diets and meal patterns, and they reflect each country's own food culture. Because of this, they provide a foundation for developing dish-based NPMs. The Japanese NPM-DJ was also designed based on Japanese food guide, so this approach can be applied in our Asian country as well. NPM-DJ is not intended to apply Japanese dish category on thresholds directly. When used in another country, the NPM-DJ is a concept, not a fixed model, and it's meant to be adapted to each country's food culture. Each country can develop its own dish-based NPM by using its national dietary guideline and using national survey data. So the NPM-DJ can serve as a flexible framework that countries can use when creating their own dish-based models. This slide shows key messages of my presentation today. First, Asian meals are based on a combination of dishes. This structure is similar to Japanese meal pattern. Second, the dish-based NPM-DJ fits Asian dietary patterns well because it evaluates nutrition at dish level. Third, the Japanese NPM-DJ can be a reference for developing country-specific NPMs in Asia. And finally, collaboration and networking in Asia are key for future development of a nutrient profiling model. Thank you very much. The source of funding and encouragements are listed here. We truly appreciate and support of an individual and organization involved in this project. Thank you very much for your attention.